This is AGNR 131, and this is lab exercise 6 called water infiltration and hydraulic conductivity in the soil. So in front of me here you can see the apparatuses we're going to use. These are called double ring infiltrometers, and we only have 2 of them set up here. We're going to have 3 set up at each site, but we're just going to show you that we have 2. We've got them separated a certain amount apart. I'll talk about that in a second. And then you can see all the stuff that we need here. We've got a ruler, you can see we've got a hammer and a piece of 2x4. I'll show you what that's used for in a minute. A couple different cups here. Lots of water, we're going to need lots of water. So from some of the previous lab exercises, what you've seen us demonstrate, or we've demonstrated, the importance of water not only being able to infiltrate into the soil, but also to be able to transmit through the soil. And we've talked about soil properties such as texture, consistency, plasticity. What are some of the others we talked about? Organic matter was another one. That were all part of the process of how, or part of the soil's ability to, or I should say, they determined how well the soil was able to not only infiltrate water, but to actually transmit water through that zone. So what we want to do today is we want to build on that, but we want to actually look at 4 different scenarios. And we have one of our scenarios right here in this lovely lawn that has just been watered. I'm stepping on it, and we just dug our finger into it, and it's very moist. So I mean, we're not going to get mud on our boots, but if I stomp my foot up and down, I could actually make some nice compacted divots in here just from my shoes. So that's important to remember what I just said there. Soil's obviously just been irrigated sometime this morning. We're at about a little bit after noon, and there's a lot of moisture here. So what we're going to do today, we have 4 sites. What we're going to do today is we're going to actually let water sit into these rings, and we're going to observe how water is able to move down through the soil profile. Okay, now we're not going to actually see the soil profile, but what we're going to do is we're going to measure the water level changing from the top of one of these rings to the bottom of these rings. So the 4 different scenarios, I just explained this one. This is the lawn, and so what happens on the lawn, you can see we're standing on it. Obviously tractors go back and forth to mow it. Irrigation actually happens on this lawn. We're in kind of a quad area, so there's some cement pathways around us that people will walk on. I'm assuming that perhaps even people walk across this lawn at times. So that's the first scenario. Now at this scenario, since we have some lovely shade here as well, I'm going to demonstrate how we actually set these double rings up, and then I'm going to explain exactly what we're doing. So I'm going to get down on my knees here and show you what we do. So and I'm gonna have wet marks on my knees. I can feel it. So here's the double ring infiltrometer. You can see 1 ring, 2 rings. Here's a handle. So what we're gonna do is, now this is gonna be easy here, but what we do is we actually put this 2x4 across it, and I have a mallet with a rubber head on it. And what I want to do is I want to actually pound this thing in gently into the soil. Right? I just want to get those rings into the soil here, and I'm going to put it on both sides, back and forth, and get those in. Now they don't have to be in too deep. All I really want to do is I want to make sure that water's not going to spill out the sides of that. So I've actually done that. So what I need to do right now is I need to very carefully just look around the edges, because it's pretty hard to actually put these rings in straight. When you pound them in, you're pounding them in like this. So you end up with a couple little, sometimes you get a little bit of a space there next to the edge of the ring. So I'm just going to gently push that down on both rings there. I want the water to actually not be tempted to run down the sides. There's less likelihood of that doing that when it's moist, but as you'll see some of our other scenarios, it's a little bit different going on there. So that's kind of there. You can see that's actually in there. I could pull it out. I probably could rotate it if I gave it a little bit of energy, but I'm not going to do that. So now, what is the logic of this? Let me pull this other one up here, which we'll put in the ground just a second. The logic is we're actually measuring water infiltrating hydraulic conductivity through the soil, right? Infiltration to the surface, and then hydraulic conductivity through this system, if you will, through the soil profile. So the way for us to actually do this consistently is that we're going to fill this outer ring. We're going to fill this outer ring with water. We're not measuring the outer ring. We couldn't care less how much water is in here, but what we want to do is we want to fill this water up. We want to keep this water filled up. So the idea would be that we want to saturate our soil. We want to saturate the soil so the whole soil is saturated around this ring. What we're going to measure then is that all the conditions are the same. We're going to fill the inner ring with water, and the water is now going to be moving straight down, because there's no reason for the water to move out because it's already been saturated in this outer ring. So the water should move straight down this column that's represented by this center ring through here. And this is what we're going to measure. It's going to be on a timed basis. Keep this filled up, and that's why we have the ruler here. We'll measure it over a period of time. So what we're going to do next is I'm going to get this one put in, but you don't need to watch that. So what we're going to do now is we want to start this process of keeping this outer ring full. So I can actually do this. If I'm careful, I can just do this even with this. I'm going to try it with this. Nope, that's not going to work too well. So this is kind of slow, but all I really want to do is just fill this up. And this works better. This works better with a couple people because it can, some of the conditions are pretty quick to get this saturated. I'll give it a little bit more. And there you go. That's pretty well filled to the top. As this goes down, I'm gonna keep it filled, and we're gonna let this sort of steady state for about 30 minutes. We're just gonna make sure that it continually stays full, and that the soil surface or the soil profile underneath this outer ring is totally saturated. Okay. Okay. So here we are at our second scenario, and this is totally different. You can see that there's walkways all around us. This looks like it was an old garden. I know that there's been nothing planted here for at least 5 years. It's right in the line where people could shortcut across this. It hasn't been watered, but it's obviously gotten wet at different times. But there's been no management of traffic. So this is kind of what we're gonna see as a theme here. How the soil has been used, how it's being used, how it's been managed, what it's used for. Those factors might overcome all the other factors, say like texture or structure or any of those other kinds of things that might explain how soils logically, water would move through soils logically. The management factor might override any of those other factors. In other words, you might have the same exact soil, the same texture, the same structure and everything, but if it's been managed differently, if it's had different inputs, different influences, if you will, then the hydraulic conductivity, the water movement through both into the soil, infiltrating into the soil, and actually moving through the soil might become very different. So much different scenario. It was hard to get these rings in. We pounded the heck out of them. We didn't even actually get them in straight. We actually had to do a little bit of manipulation because they bounced around a lot because the soil was so hard and dry that we had to make sure that the edges were kind of sealed because they're kind of wobbled back and forth as we got them in. So a little bit of weirdness there, but we're going to go ahead and fill these up with water and do the same thing. Wait our 30 minutes, get those outer rings full, and wait our 30 minutes, and then come back and we'll start running our experiment on that.